Hello, I want to give a quick overview over my 32-bit integer hardware calculator made in Logisim. So, down below, I got this input pad for the user. We have number 0 over 29, negate, clear entry, clear, backspace, divide, multiply, minus, add, and calculate. Those get fed into this input buffer, and this guy translates those user inputs to signals that my circuits behind understand. If we follow those signals, we end up mostly over here and also over here. Now this handles the BCD inputs and generally outputs whatever the user has input on the top. And on the bottom we have the BCD outputs. Those get fed into the BCD to binary converter. We got, let's say we have a 34 inputted, then we have a 3 and a 4, then we calculate the 4 times 10 raised to the power of 0, and the 3 times 10 raised to the power of 1, which is 10, this times 100, 1000, and so on. We add up all numbers and spit out the result into here, into this small circuit. This is not really necessary. It only optimizes the multiplication runtime by a little bit. For this I have to know which function I have selected. And we see it comes out from this function converter. This takes a look at the inputs. Let's say we have a positive number plus a negative number. Then this is the same as subtracting instead of adding. And this one takes the function directly from the input buffer and also leads them into this small circuit which displays the operation. Back to this calculation unit. The goal for me for this calculator was to have as much functionality in the smallest amount of adders for me possible to realize. So over here I got one adder for the low 32 bits, one adder for the high 32 bits. I only have this subtractor here, which has nothing really to do with the numbers outputs. And also this adder over here, which only negates the output if needed. Let me zoom out a bit. Okay, this looks quite messy, and it is. But the basic idea is we have these two numbers, and most of what they do is input over here, traverse those signals, and output back here. And everything below is just the control circuitry to make all operations happen on those two circuits. For the output, we have low 32 bits. For the multiplication, we have also high 32 bits. And for division, we have a remainder. Then those get fed into this shift unit over here, which shifts the bits bit by bit into these controllers that convert the binary stream of bits into BCD and display those. So let's make an example. Say we have 34 plus negative 12, and then first of all we have a 3 and a 4, then we have a 1 and a 2, and when I hit the start calculation button we will see those two numbers on those lines. So here we have a 34 and a 12. And the operation here, the function is a 0, which corresponds to a plus, the addition. And on the output of the function converter we have a 1, which in this case would correlate to subtraction instead of addition. Then inside the calculation unit we calculate the output, which with addition is pretty much instantly. We get a 22. And finally on the output we will see the bits rolling in on this line. For this demonstration purposes I enabled the display, so you can see how the numbers pile up. So 1, 2, and so on. Let's make an example with larger numbers. Okay, first of all, we have all our numbers here. 1, 1, 0, 0, 0, 0, and we should see these 1 billion on those lines. And we do. Then we calculate the output in here, the low and the high register. And as soon as we are done, we see the output on these 2 lines. May take a while. Now it's done. We see this is complete rubbish because we need more than those 32 bits. And then we begin to feed in the bits over here, one by one. And if you look closely, you can see a pattern. We are multiplying the number each time by 2 and add whatever, and add 1 if this is active. And this is the result. Down in the bottom we also have those lamps, which basically indicate at which stage we are. So the BCD to binary, you should know by now, is this part over here. Then the calculating happens in here. And the binary to BCD with the help of the shift unit and the controllers is done over here. Okay, if you have any questions regarding this circuit, leave them in the comments and I will take a look at them. Peace.